Okay, I just wanted to give a quick explanation of what a subnet mask is. So, we're all familiar with masks. Some of our favorite superheroes wear masks, right? So, what's the job of the mask for a superhero? Well, it's to hide part of the person's identity and show part of the person's identity. So, with Spider-Man, we can see his eyes, and we can see a little bit more of Batman. He covers his less of his face up than Spider-Man. And if we take the mask away, we can see these guys. Okay, see their whole face. Put the mask on, and we only see the part that they want us to see. A subnet mask is the same idea. Okay, so you take an IP address. Routers really don't care about IP addresses. Routers care about network addresses because the job of the router is to connect different networks together. It's not really the router's job to get an IP packet to individual computers. It's the router's job to get it to the correct network and then let the switches take care of it from there. So the same thing, we set up subnet masks depending on how we want to use our IP address. Okay, so some different examples. Really, so you'll see a subnet mask that looks something like this. So 255.0.0.0 would only show the very first number. So what's happening is a logical AND operation. When you have 255, that's 8 ones. Okay, and when you AND anything with a 1, you get back out what you put in. So whatever the binary version of 172 is, ANDed with all ones, it shows up. However, when you AND anything with all zeros, so if I have 8 zeros in the mask like I do here, no matter what the bits are, they're going to come back out as zeros. So that's what ANDing this mask with this IP address would wind up looking like. And so here's another example. If I have two sets of ones, or 255, 255.0.0, then I'm going to see the 172.217 address, and the rest would turn out zeros. And so these zeros this is a network address then that the routers can route between. It really doesn't care about the last numbers there. That's once it gets on the correct network. Okay, one more example. So here's a subnet mask with 3 255s in it like that. So now we can see the third number, and that fourth number gets set to all zeros. So that's what's really happening. These 255s denote the positions or the numbers that we want to see, and the zero part, we want to turn it into zeros like that. So a quick example, let's say I have a network here, and where's my IP address that I want to use again? Okay. As it turns out, this is a Class B network. So that's by default, that's the default mask for a Class B network, which is all fine. But if I have multiple networks that I want to use this same network address for, I need to use some extra bits to describe. In this case, I've got 3 different networks that I want to use. Okay, so what I would need to do is switch to a mask like this that gives me some more bits to work with. So now I'm seeing a 9, so I could go 172.217 9.0 for this subnet, and then I would need to change this number for the other two. So 172.217, maybe a 10.0 for this subnet, and 172.217 11.0 for this subnet, something like that. And then you would base your IP addresses off of that. So as long as there's a 9 in all of these three machines plus the router, and a 10 on these connect. So let me just give you an example. Let's do the connection between the routers here. 172.217.10.1 on this interface of the router, and then over here we'd put 172.217.10.2 for this interface. And we would be using the 255.255.0 subnet mask, and that will and we'll use that mask on everything. So if I do IP addresses on this side, it'd be 172.217.9. Let's say 4 here. And let's give the router the .1 address, 172.217.9.1. So that's the router's address on that side. And again, we would use this 255 times 3 on each device. And then, so that'll be used, whatever you decide to use for your subnet mask, it gets applied throughout the entire network, like so. So we can look at it and see, okay, there's a 9 there, there's a 10 there, there's 11 over here. So what would you say the IP address for the router would be on this side? Well, 172.217.11, and we can just do a .1 on that one as well. Okay, as long as those numbers match on whatever network that you happen to be on, then they can talk to each other. So this one, if you want to set this computer up, 172.217.11. I've run out of room, but we'll call that one .2. Okay, and again, don't forget your subnet mask with the 3 255s followed by 0. So when you're configuring these devices, you need that. Now, one more quick point, and then I'll let you go. So because the routers are gateways, they don't need a gateway address. But these other devices that are living on a network, if they want to talk to a machine on a different network, they need to go through the router. So they need their router's address. That's why when you're configuring IP on a computer, it always asks for what's the gateway address as well. So we've set up 9.1 as our router's address that we're attached to. So the gateway address in this case would be 172.217.9.1. And so if I know that address, I can talk to the router, and the routers will talk, and I can talk back and forth that way. All right, so that's my basic introduction to subnet masks and what those 255s mean. Basically, they say if there's 255 there, take a look at that number. You can let that through, and if there's a 0, block it out, turn it into zeros. We don't care about it, because the routers really only care about what's the network that I need to deal with here. So from now on, whenever you think of subnet masks, think about how the mask hides part of the IP address and allows the network address to show through like that. So yeah, whenever you think of a subnet mask, remember our little superheroes, and that the mask masks out part of the information and lets part of the information through.